Hello there and welcome back to the Sleep Science. You're standing under a sky that looks like it's been spilled across black velvet, a sprawl of glittering dust and cold stars humming with their own secrets. Somewhere out there, far past Pluto's lazy orbit and the Kuiper Belt's frozen drift, something moves that shouldn't even exist. A ghost from another sun, another age, 3I/ATLAS, sliding through our cosmic neighbourhood as if the Milky Way itself accidentally dropped a marble into our yard. You squint at the faint teal shimmer on your telescope app and realise this isn't just another icy snowball from our backyard solar system. This one doesn't belong here at all. It's an interstellar visitor, the third ever spotted, and brace yourself. It's breaking every comet rule in the book. You probably won't survive this amount of nerdy excitement. So, before you get comfortable, take a moment to like the video and subscribe, but only if you genuinely enjoy what I do here. Drop a comment telling me where you're watching from and what time it is in your corner of the planet. Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You lean closer to the telescope feed, the digital glow soft on your face. Out beyond Neptune, a faint blur is gliding through the void. Most comets are like loyal pets. They circle the sun for eons, predictable, obedient to gravity's leash. But 3I/ATLAS. It's a feral thing, untamed and fleeting, on a one-way path through the solar system, a traveller that will never return. Astronomers first noticed it in 2024 when the ATLAS survey, short for Asteroid Terrestrial Impact Last Alert System, flagged an object moving far too fast, on an orbit too hyperbolic to be born here. At first, they thought it was a glitch. The sky is noisy, computers misbehave, but the numbers were insistent. This was real. The realization hit like cold caffeine. Humanity was witnessing only the third known interstellar comet ever discovered. The first was the infamous 1I/Oumuamua in 2017. Remember that flattened space cigar everyone argued about for years? Then came 2I/Borisov in 2019, a more classic comet but still a visitor from afar. And now 3I/ATLAS had entered the stage, its icy body whispering of alien suns and distant planetary nurseries. Historians still argue whether Oumuamua even was a comet or some shard of lost technology, but Atlas didn't care about debates. It came spinning in with a confidence that suggested you haven't seen anything yet. Under the telescope's eye, its tail gleamed an unnatural greenish blue, as if someone had taken an aurora and twisted it into a ribbon. Normally, a comet brightens as it nears the sun, its surface warming, ices vaporizing into gas, sunlight scattering through the dust. But early observations hinted that ATLAS was cooling. Its coma, the cloud of gas surrounding it, wasn't expanding as expected. Instead, it was shrinking, like a cold breath drawn inward. One researcher joked that maybe ATLAS had read too many self-help books and was learning to set boundaries. You can almost feel the hum of the data servers as they churn through terabytes of sky maps. There's something hypnotic about it, an orchestra of photons captured by telescopes in Hawaii, Chile, Spain. Astronomers sip their midnight coffee, arguing softly about orbital mechanics and thermal inertia. It's oddly comforting knowing there's a whole community of people awake with you, staring into the same infinite black and trying to make sense of a glowing speck. Through the digital reconstruction, you imagine Atlas as a lump of glittering frost about half a kilometre wide, rotating lazily like a stone skipping through molasses. Interstellar space has scoured it for millions, maybe billions of years. Every ridge and crater on its surface carries the memory of another star's warmth. Its composition, scientists suspect, includes exotic ices never before seen in our neighbourhood. Carbon monoxide frozen so hard it rings like glass. Molecular hydrogen trapped in crystalline pockets. You picture it tumbling, pieces flaking off like cosmic dandruff, releasing alien snowflakes that will burn away long before they ever reach Earth. And yet, there's something more. Something wrong, or maybe too right. The comet's brightness fluctuates not randomly but rhythmically, as though pulsing. One amateur astronomer even claimed it blinked like a heartbeat, though professionals brushed it off as coincidence. Still, you can't help noticing how the data curves rise and fall in a pattern suspiciously close to regular. Historians still argue whether ancient cultures noticed similar rhythms in the sky. Some Babylonian records mention stars that breathe, though modern scholars tend to file those under poetic exaggeration. Still, the echo feels uncanny. You imagine standing in an ancient field thousands of years ago, looking up without telescopes or computers. A streak of light appears, green and uninvited. Would you think it was a sign from the gods? A warning? Or would you, like the modern astronomers, simply whisper, "That's odd," and reach for your notes? Humans haven't changed much. We still turn mystery into mythology. Atlas just happens to be the latest chapter in a very old story. A gentle chime from your imaginary observatory console tells you the data stream is steady. The comet's trajectory confirms it's not captured by the sun. It's a true interstellar drifter, just passing through. Its speed, nearly 60 kilometers per second, is fast enough to ignore our star's gravitational pleading. The equations don't lie. It came from somewhere beyond. Maybe the void between the stars in Lyra, maybe further. And when it leaves, it will head toward Perseus, carrying our curiosity with it. You lean back, the hum of the fan mingling with the cosmic silence. For a brief moment, the line between science and awe blurs. You're just another tiny observer floating in an ocean of space, watching something ancient and indifferent cross your sky. And that somehow feels intimate. You chuckle softly. Somewhere, a sleep-deprived grad student is probably naming a spreadsheet column after you. Somewhere else, a conspiracy theorist is already uploading a video titled "NASA Hiding Third Alien Comet." Balance, you think. The universe always finds it. The night deepens. Atlas keeps moving, slowly rewriting everything we thought we knew about how comets behave. Its light flickers one more time on your monitor before fading behind a digital timestamp, and you can't shake the feeling that you've just met something that doesn't belong to this solar system, or maybe even to this time. You wake up still thinking about that teal ghost gliding through the void, and before your first sip of coffee, you're already scrolling through the night's new data drops. Atlas isn't alone after all. It's just the latest chapter in a very short, very dramatic saga of interstellar comets crashing our otherwise peaceful solar party. Before it arrived, we only knew two of its kind, 1I/Oumuamua and 2I/Borisov, two cosmic guests who couldn't have been more different if they'd tried, and yet both rewrote our textbooks faster than a freshman panic editing at 3 a.m. You remember 2017, the year the world first whispered the name Oumuamua. Discovered by the Pan-STARRS telescope in Hawaii, it came screaming through the inner solar system on an orbit that no gravitational math could domesticate. Long, thin, spinning end over end like a lost baton, it reflected sunlight in a way that suggested metal, or maybe frozen hydrogen, or maybe something we still can't define. Historians still argue whether it was a comet at all or an asteroid, or, if you're feeling bold, a fragment of alien debris. One Harvard astronomer even published a paper suggesting artificial origin, and the internet did exactly what you'd expect with that headline. Then came 2I/Borisov in 2019, a much more traditional snowball. It had the classic coma, the dusty tail, the chemistry that screamed comet. Yet its velocity and composition confirmed the interstellar passport stamp, icy material that likely formed around another star. It was the first time humans could say with certainty, we've sampled another solar system without leaving home. A historical first, quietly monumental. Compared to those two, 3I/ATLAS feels like the unruly third sibling. Brash, unpredictable, and possibly smarter than it lets on. When it first appeared, astronomers thought, oh good, another interstellar comet. Maybe this one will behave. Spoiler, it did not. Its trajectory bent just slightly less than predicted, its albedo shimmered oddly, and its tail, if you could call that luminous fog a tail, shifted direction in defiance of solar radiation pressure. If Oumuamua was the mysterious flatstone and Borisov the icy cannonball, ATLAS was a ghost wearing a mirror. You picture the night of discovery. The Atlas system, a network of robotic telescopes scanning the heavens for killer asteroids, spots something faint moving across consecutive images. At first, the algorithm throws it in the probably noise bin, but one technician, a young astronomer with a habit of triple-checking, runs the data again. The object's motion doesn't match any known asteroid path. It's too fast, too hyperbolic. A notification pings across research networks. Possible interstellar origin. That's like shouting unicorn in a zoo. Within hours, observatories from Chile to the Canary Islands are aiming lasers and mirrors into the darkness, trying to catch the wanderer before it fades. What's strange about interstellar comets is how personal they feel. They're messengers from other suns, little frozen memory sticks carrying chemical data older than Earth itself. You imagine each one spending millions of years adrift between the stars, enduring radiation storms and absolute cold, before accidentally wandering into our gravitational field. For most of that journey, they're as inert as pebbles, but once sunlight touches them, they wake up, hissing, glowing, shedding secrets. Some astrophysicists joke that our solar system must have pretty good curb appeal, because we keep luring in weird visitors. Others wonder if this is normal, that perhaps interstellar objects pass by all the time, but we only recently built eyes sharp enough to see them. Historians still argue whether ancient astronomers might have glimpsed one and mistaken it for an omen, a dragon, or a divine torch. Maybe the Chinese chroniclers who wrote about a broom star moving backward in 134 BCE weren't seeing Halley's Comet after all, but something stranger that never came back. It's the kind of thought that makes you glance at the sky a little differently. You sip your coffee, imaginary but hot enough to wake you, and think about how fragile these discoveries are. Oumuamua was detected after it had already passed its closest approach to the Sun. By the time we noticed it, it was already leaving. Borisov we caught earlier, but even then we only had a few months of data before it faded into darkness. Atlas, at least, arrived in the era of hyper-connected science. Machine learning now trawls the skies nightly, catching faint blips that would have gone unnoticed a decade ago. Somewhere, a neural network is literally dreaming of comets so we can study them while we sleep. A little side note. In ancient Rome, comets were considered harbingers of political chaos. Julius Caesar's death famously coincided with one so bright it could be seen in daylight. Historians still argue whether that celestial event was Halley's Comet or some other visitor, but it left a mark on culture that still glows 2 millennia later. You can't help smirking at the irony that now, in our ultra-rational age, a new comet can still ignite almost the same mix of awe and anxiety, only now it happens on Reddit instead of in the Senate, back to ATLAS. The more astronomers watched it, the stranger it became. Its nucleus seemed to fragment, then reform, like something tearing itself apart and changing its mind mid-process. Spectroscopy showed gas signatures inconsistent with any known solar system ice, and as if craving attention, its tail began pointing toward the sun rather than away, like a flag in a reverse wind. The forums went wild. One researcher tweeted, "Either our physics is wrong, or the comet didn't get the memo." That's the tone of the whole affair, half wonder, half bafflement. You imagine the research papers piling up like detective notes on a corkboard, each one connected by red string labelled unsolved. And here you are, lying in bed with your earbuds in, feeling that same pulse of curiosity beating under your skin. It's the same pulse that moved Babylonian priests, Renaissance astrologers, and now sleep-deprived astronomers staring at pixelated dots. Some mysteries don't age, they just get better Wi-Fi. The night outside your window deepens, the kind that makes city lights feel like small artificial stars. Somewhere above, Atlas continues its strange arc, probably laughing in Comet if it could. It doesn't care what we call it, asteroid, visitor, messenger. It just keeps moving, serene and untouchable, trailing light from another world. It begins, as so many cosmic stories do, with disbelief. You picture a control room in Hawaii, the soft blue of monitor light flickering across the faces of scientists too tired to remember what day it is. One of them squints at a faint blur that refuses to behave. The software insists it's just a random smudge, a cosmic ray streak, a momentary burp in the data. But the human eye, still the best pattern recognition tool in the universe, senses something deliberate about its motion. That's how 3I/ATLAS first entered our awareness, as a blip no one believed. The Atlas survey isn't a glamorous operation. Its twin telescopes watch the night sky the way security cameras watch parking lots. Constantly, patiently, scanning for anything that moves wrong. Each night they collect gigabytes of data, then hand it off to computers trained to flag potential hazards. Most of the time, those hazards turn out to be satellites, dead pixels, or the occasional over-enthusiastic moth. So when a streak appeared that didn't match any known satellite track, One technician muttered, "That can't be right," and marked it for deletion. But something about its speed bothered him. He double-checked, then triple-checked, still wrong, which in astronomy is the best kind of right. The next morning, he sent the coordinates to a colleague at the University of Maryland. Probably nothing, the note said, but worth a peek. Within hours, other observatories pointed their instruments that way, and there it was again, faint but undeniable, crawling across the background stars like a lost thought. Its brightness curve didn't match any asteroid, and its path was too steep for anything gravitationally bound to our Sun. By midnight, the object had a provisional designation, C/2024R3, Atlas. The C meant comet, though even that felt presumptuous at the time. In those first 24 hours, every possibility flickered through the chat logs. A rogue satellite fragment, a piece of interplanetary debris, a data processing bug that had somehow survived 3 cross-checks. One astronomer even joked that it was probably just Elon's latest vanity project. But the numbers spoke clearly. The orbital eccentricity, 1.2, was greater than 1, the signature of a hyperbolic escape path. Translation: this thing was not from around here. You imagine the tension in the room as confirmation rolled in from Chile, then Spain, then South Africa. Each new telescope frame locked the orbit tighter, and with every refinement the object's origin grew more impossible. Someone finally typed the phrase into the group chat that would later headline dozens of articles. We might be looking at another interstellar comet. Cue the collective gasp. Well, as much as scientists gasp. It's more of a subdued, huh. But underneath that composure runs pure adrenaline. Discoveries like this are once-in-a-career events. The first interstellar object, Oumuamua, had caught us off guard. Borisov we'd managed to chase properly. Now Atlas had arrived with just enough warning to test how much humanity had learned in the meantime. Spoiler, not nearly enough. There's a beautiful irony in how Discovery feels so small at first. Just a few pixels, a faint smear on a screen. Yet entire fields of science pivot around that moment. Somewhere between the first confirmation email and the third pot of coffee, the observers realized they'd just opened another window into the galaxy. It's the sort of realization that hits slowly, like dawn. You tilt your imaginary telescope toward the same coordinates. The comet looks faint, its coma, a hazy shell of gas, barely visible against the black. And yet the longer you stare, the more alive it seems, as if it's aware of being watched. That's when the weirdness starts. Over consecutive nights, its brightness fluctuates wildly. Bright one evening, dim the next, then bright again. Standard comet physics says sunlight heats the ice. Ice turns to vapor. Vapor glows. Simple. But Atlas's light curve made no sense. It pulsed. Not perfectly, but regularly enough to give data analysts mild existential crises. A mainstream historical fact drifts through your thoughts. In 1610, Galileo turned his telescope toward a comet and declared it a simple optical illusion, a substance of the atmosphere. He was wrong, but his mistake reminds us how slippery truth can be when light and distance conspire. Historians still argue whether that error delayed our understanding of comets by decades or saved it from superstition. Either way, you get the feeling Galileo would have loved Atlas. It's the kind of puzzle that laughs politely at your equations before rewriting them. And speaking of superstition, here's your nightly quirky tidbit. In medieval England, people believed that comets caused ale to spoil, not political upheaval or war, beer quality. Somewhere, a 14th century brewer would have blamed Atlas for a flat pint and felt utterly vindicated. Back in the modern lab, the data continued to rebel. Spectrographs showed signatures that didn't match the usual suspects like water, carbon dioxide or ammonia. There were faint hints of compounds never before seen in a comet's spectrum, molecules that, if verified, could have formed only under conditions near a red dwarf star. That possibility sent everyone into a mild frenzy. It meant Atlas might not just be interstellar, it might be from an entirely different kind of solar nursery. Imagine a rock carrying the chemical handwriting of another sun. That's the sort of revelation that turns graduate students into legends. Still, skepticism thrived. Some astrophysicists warned that early data was notoriously deceptive. Remember Oumuamua, they said. We thought it was a comet, then an asteroid, then a spaceship, then a comet again. The team laughed, but they knew the warning was valid. History doesn't just repeat, it roasts you on Twitter. You stretch, feeling the steady hum of cosmic quiet pressing against your eardrums. In that silence, every new detail feels intimate. A faint change in tail direction here, a sudden drop in brightness there. It's like learning someone's moods through long observation. You start to anthropomorphize the comet, which is a very human thing to do. You imagine it shyly hiding its secrets, flashing a bit of light only to retreat again. Maybe it knows it's being watched by creatures who can barely comprehend their own orbit. The scientists, of course, stayed professional. They logged, analysed, and debated. But between the lines of their reports, you can feel the excitement vibrating. They were seeing something unique, and that realisation hummed like static under every paragraph. By the time the official designation switched from C/2024 R3 to 3 I/ATLAS, the I marking its interstellar citizenship, the disbelief had melted into awe. The blip that nobody believed was now the comet that would challenge every model we had. Out beyond Neptune, the teal ghost kept moving, silent, indifferent, its tail whispering against the vacuum. For it, nothing had changed. But for us, everything had. You watch the comet's strange tail shimmer across a digital sky, and something in your brain whispers that shouldn't be possible. The tail, that delicate streamer of gas and dust, is supposed to behave like a well-trained ribbon in a breeze, always pointing directly away from the sun, pushed by solar radiation and wind. It's the most basic rule of comet physics, taught in every Astronomy 101 lecture since Edmund Halley first made comets predictable. And yet 3I/ATLAS seems to have skipped that class entirely. Its tail bends the wrong way. You scroll through the telescope feed again just to be sure. Nope, still reversed. At first, astronomers thought it might be an optical illusion, some trick of perspective or camera calibration. After all, space loves to make fools of confident humans. But as more observatories joined the watch, the consensus grew. The comet's tail really was misbehaving. Some nights it pointed sideways, other nights slightly toward the sun itself, a direction that should be impossible without rewriting physics or bribing photons. Normally a comet's tail has two parts, a dust tail and an ion tail. The dust tail curves gently because dust grains move sluggishly under sunlight, while the ion tail, made of charged gas, stretches straight back, guided by the solar wind's magnetic fields. But Atlas blurred that distinction. Its tail flickered between both behaviours, sometimes bending like dust, other times twitching like plasma. One researcher joked that it looked like the comet had commitment issues. The community split into camps. Some proposed exotic magnetic effects, others suspected hidden jets on the nucleus acting like tiny thrusters. Historians still argue whether early models of solar wind would have predicted something like this if we'd had better instruments centuries ago. In the 1950s, for instance, scientists were still debating whether comet tails were pushed by sunlight pressure alone or by charged particles streaming from the sun. The discovery of the solar wind finally settled that, until Atlas came along and said, "What if both, but wrong?" You zoom closer to the simulation. The tail undulates like a living thing, shimmering teal and silver. Its core brightness pulses in faint rhythm, and sometimes a ripple travels down the entire length like a sigh through fabric. Even for a digital render, it's mesmerizing. You imagine what it would look like through a real telescope under a dark sky. Just a faint smudge to the naked eye, but to knowing minds, a signature of something unprecedented. A mainstream historical fact floats to the surface of your drowsy thoughts. In 1680, the great comet of that year terrified Europe. Its tail stretched across a quarter of the sky, and people swore they could hear it hissing. Isaac Newton used that comet to refine his gravitational theories, proving that these celestial visitors followed predictable elliptical paths. Historians still argue whether Newton's careful observations of that comet inspired his law of universal gravitation. Funny, you think, how 3I/ATLAS might one day inspire another Newton moment, forcing us to reconsider what's actually predictable in the cosmos. Of course, modern astronomers are less poetic about it. They want equations, not omens, so they measure the tail's curvature, its particle density, its spectral emissions. The data makes no sense. The ion tail seems to deflect toward regions of higher magnetic turbulence rather than away, almost as if the comet were attracted to magnetic noise instead of repelled by it. That's like a sailboat steering into the wind and somehow gaining speed. A fringe theory pops up online, a blog post claiming ATLAS is using electromagnetic propulsion, the kind NASA only dreams about. Scientists roll their eyes, but still, the numbers itch. Something about the tail's geometry defies every conventional model. It's not that physics is wrong, it's that physics might not be done yet. You imagine standing on the comet's surface, which in reality would be a bad idea. No air, plenty of radiation, and roughly the texture of shattered charcoal. You feel no breeze, no heat. The sun is a distant white coin. Around you, particles lift gently from the ice, floating upward in an invisible exhale. They should scatter evenly into space, yet somehow they're streaming sideways, caught in a dance that even computers can't fully choreograph. A quirky tidbit for you. In the 19th century, before anyone knew what comets were made of, a few astronomers theorized that the tail might be a kind of etheric appendage, alive and responsive to cosmic emotion. They genuinely described comets as sensitive organs of the heavens. It's an idea that would make modern scientists choke on their lab coffee. But when you watch Atlas's living, shimmering tail, you almost understand the sentiment. Meanwhile, observatories worldwide keep collecting frames, stacking them into high-resolution mosaics. The European Southern Observatory publishes one that shows faint striations, like ripples in smoke, running perpendicular to the tail's length. One astrophysicist nicknames them veins, another prefers scars. A few late-night data analysts, armed with pizza and questionable judgment, start calling them stretch marks from creation. The nickname sticks for a week before someone official vetoes it. There's a moment sometime around 3 a.m. observatory time when a postdoc watching live data whispers, "It's pointing upstream again." That phrase, pointing upstream, becomes shorthand across the community for ATLAS's defiance. Every time the tail flares toward the sun, Twitter lights up, "Upstream again," accompanied by grainy screenshots and sleep-deprived celebration. Science, at its best, feels like communal wonder punctuated by memes. Historians will someday argue whether the upstream tail was a magnetic inversion effect, an illusion of perspective, or evidence of previously unknown interstellar material embedded in the comet's crust. But right now, in this quiet moment, you're content just to imagine it. A teal comet trailing a tail that bends against the light, carving its own strange physics across the black. The thought is soothing somehow. Maybe that's what draws people to comets. Not their chaos, but their rhythm, their graceful defiance. They move on cosmic timescales, yet they remind us how to drift, how to persist, how to shine even when the rules say we shouldn't. You glance once more at the monitor. The tail flickers like a heartbeat, folds, then blooms outward again. Somewhere, in that shimmer, lies a truth we haven't named yet. And the beauty of it is, you don't have to rush. The universe will wait. You wake from an uneasy doze, the kind where your dreams still hum with data. In them, numbers scroll past like fireflies. Speed, spin, brightness, angle. You can almost hear them whispering their defiance. None of this adds up, they say, and they're right. For 3i/ATLAS, the math never quite behaves. You pour yourself a pretend cup of midnight coffee and slide back into your seat at the imaginary console, ready to chase those stubborn numbers until they confess. The first number that refuses to play nice is the velocity, around 60 kilometers per second relative to the sun, fast enough to make Mercury dizzy. That's quick, but not unprecedented for an interstellar object. What is strange is the way its acceleration fluctuates. Every few weeks, Atlas seems to gain or lose a few centimeters per second, like something inside it is subtly pushing or braking. Radiation pressure can do that, sure, but not this precisely, not in these directions. Then, there's the rotation rate. Most comets spin with a kind of lazy tumble, anywhere from a few hours to a few days per rotation. Atlas, by contrast, twirls like a performer unsure which direction the spotlight is in, jerky, inconsistent, unpredictable. Early light curve readings suggested a rotation period of about 10 hours. A week later, it was measured at 13, then 9. Either the comet is rearranging its own spin mid-flight, or our models are missing something. Historians still argue whether earlier anomalies like Oumuamua's odd motion were caused by outgassing jets or by something more exotic. With Atlas, that argument returns in full cosmic stereo. You zoom in on a reconstruction of the nucleus. Picture something about half a kilometre across, an irregular lump of dirty ice, pocked with pits that vent gas when sunlight hits them. Every vent acts like a tiny thruster, altering spin and trajectory. But Atlas's changes don't match any logical vent pattern. They're symmetrical, almost rhythmic. If it's random, it's the most polite randomness you've ever seen. The albedo, its reflectivity, is another headache. The comet shines more brightly than expected for its size and distance. Some patches of its surface reflect nearly twice as much light as typical cometary ice. Maybe it's fresher material, one researcher shrugs, or crystalline carbon monoxide. But another suggests, only half joking, maybe it's polished. The idea earns a round of laughter and one quiet note in the official record. Science never deletes a possibility, no matter how absurd. A mainstream historical fact drifts into focus. In 1705, Edmund Halley used Isaac Newton's laws to predict the return of a comet, the one we now call Halley's. That moment marked humanity's first confident handshake with celestial mechanics. We learned that comets, however wild, were predictable. Historians still argue whether Halley's success transformed comets from omens into mere physics problems. If so, ATLAS seems determined to drag them back into mystery. You scroll through graphs. The brightness curve jumps again, forming an almost musical pattern. Someone on a forum plots it as sound and swears they hear rhythm. Not music exactly, more like the flicker of a heartbeat recorded through static. Another user overlays the pulse atop Oumuamua's light curve, and the similarities spark all sorts of conspiratorial poetry. The official line remains, "Interesting coincidence," but you can practically hear the universe winking. A quirky tidbit surfaces. In 1957, a Soviet mathematician suggested that comets might be frozen radio transmitters left behind by ancient civilizations, broadcasting data via natural oscillations. The paper was politely ignored, but decades later it makes for a deliciously ironic footnote. If that mathematician could see Atlas now, with its flickering, number-defying behaviour, he'd probably feel vindicated enough to start a podcast. You look at the latest 3D thermal model. Its temperature map resembles a patchwork quilt, hot spots glowing where there shouldn't be heat, cool zones where sunlight blazes directly. Normally, the sunward side of a comet steams with vapour, while the far side freezes solid. But Atlas has it backward. One simulation shows heat apparently migrating under the surface, like the comet is redistributing it deliberately, equalising its temperature to avoid cracking. That's not behaviour, that's strategy. Of course, no one's suggesting consciousness here, except for the internet, which immediately does. There's a whisper of friction between camps, the observers, who trust what they see, and the theoreticians who demand the math behave. Every new dataset becomes a small academic drama. Our measurements show non-gravitational acceleration consistent with jet activity, but the direction doesn't fit the geometry. Then the geometry's wrong. Then physics is wrong. Then you're wrong. And so on, usually ending with someone bringing muffins. Science may be slow, but it's surprisingly civil. Historians still argue whether the early space-age concept of non-gravitational acceleration was invented to save face for comet models that couldn't explain anomalies. If so, ATLAS is now the patron saint of face-saving. Every time its numbers refuse to behave, someone invents a new term: differential sublimation torque, localized recoil, anisotropic mass loss. Translation: we have no idea, but it sounds impressive. You lean back, letting the numbers dance across your vision. There's something oddly comforting about the chaos. It reminds you that the universe isn't a spreadsheet. It's jazz. Improvised, surprising, occasionally offbeat, but somehow harmonious in ways we can't yet score. Your eyes drift toward the live feed again. The comet glows faintly, a soft pulse against the black, its tail trailing a whisper of teal light. You imagine the photons leaving that surface right now, racing toward Earth, destined to slam into telescope mirrors and camera sensors, transforming into pixels, into data, into debates, into wonder. Maybe that's the real math of it, the exchange rate between mystery and meaning. The numbers don't have to behave, they just have to keep us awake a little longer, staring upward. You chuckle softly, realizing the coffee's gone cold. Somewhere across the planet, hundreds of other scientists are doing the same thing, sipping caffeine, muttering at data, falling half in love with an impossible comet. Atlas doesn't know or care. It just spins, bright and erratic, numbers be damned, carving equations into the dark that we'll spend decades trying to solve. You picture yourself inside an observatory at 2 in the morning, the kind of hour when silence has texture. The dome above you is half open, a steel eyelid staring into forever. The telescope hums softly as it tracks 3I/ATLAS, that rebellious point of teal still refusing to obey anything but its own physics. You're not alone. Across the world, every major telescope capable of seeing that faint visitor is awake too. Giant mirrors, sensitive CCD arrays, and adaptive optics all pivot in slow synchrony, like an orchestra tuning for a cosmic symphony no one has rehearsed. Astronomers call this coordinated observation mode, but it feels more like a stakeout. The Gemini Observatory in Hawaii, the Very Large Telescope in Chile, the Keck Twins, Subaru, even a couple of scrappy amateur setups in Arizona and Namibia, all chasing the same flicker. Every few seconds they feed data to a shared network that stitches the sky together in real time. It's a beautiful thought. Hundreds of minds separated by oceans, connected by a single speck of light that doesn't belong to any of us. The instruments themselves are half the story. You walk past racks of fibre optic cables and liquid nitrogen tanks. Each hiss sounds like a sigh from the universe. Detectors cooled to -200 degrees Celsius catch photons that have travelled billions of kilometres, each one a tiny survivor carrying the comet's gossip. The adaptive mirrors adjust every millisecond to counteract the Earth's atmosphere, flexing so subtly that you can barely see the movement. Somewhere in the data stream, ATLAS glimmers, dim, jittery, but alive. A mainstream historical fact drifts across your mind. In 1846, Johann Galle used the Berlin Observatory's telescope to spot Neptune exactly where mathematicians predicted it would be, proving that numbers could summon planets from darkness. Historians still argue whether that discovery marked the triumph of theory over observation, or the perfect marriage of both. Tonight, chasing Atlas feels like that balance again. Half intuition, half equation, all caffeine. You listen to the ambient sounds around the observatory. The ventilation system purrs, laptops click, someone coughs quietly into the night. Astronomers aren't glamorous heroes, they're patient listeners. They spend hours staring at what looks like noise until the universe finally whispers back. One grad student monitoring the feed mutters, "Come on, do something weird." Everyone laughs, but the comet obliges anyway. Its tail brightens unexpectedly, a brief flare that lasts just 20 minutes. Immediately the data channels explode. "Event detected," one message reads. Another adds, "Could be outgassing." But the spectrographs tell a stranger story. Instead of the usual water vapor or carbon monoxide spike, they detect a narrow emission line near 630 nanometers, something faintly reminiscent of excited oxygen, but shifted just enough to raise eyebrows. It's not proof of alien chemistry, but it's not nothing either. You imagine the collective thrill running through every lab. This is why people spend decades chasing dim smudges across the sky. Then comes the human side. Someone spills coffee on a keyboard, another accidentally leaves a hot mic channel open, filling the global feed with an unfiltered string of mild profanity and laughter. In the background, the comet continues to glow, utterly indifferent. There's comfort in that indifference. It means we can project whatever meaning we need onto it without consequence. A quirky tidbit sneaks in as you scroll through historical notes. In 1783, the astronomer William Herschel reportedly saw luminous tendrils in a comet's tail and wondered if they were filaments of life or electricity. 2 centuries later, the term plasma replaced both possibilities, but Herschel's poetic phrasing lingers in archives. You smile at the thought that even great scientists sometimes dream beyond their data. As dawn approaches in Hawaii, the giant telescopes hand off observation duty to their European counterparts. It's a relay race across time zones. From La Silla to Mauna Kea to Paranal, ATLAS never leaves the spotlight. Each observatory contributes a few precious minutes of clarity before clouds or sunrise interfere. When stitched together, the images reveal a time-lapse of the comet's slow pirouette through space, its fragmented jets sparkling like frost under a strobe. Historians still argue whether modern astronomy's obsession with coordination has made discovery too bureaucratic, too committee-driven. But in this case, teamwork feels like necessity. One telescope sees shape, another sees colour, A third captures spectra, and only by combining all three do we glimpse truth. Alone, each data stream would just be noise. Together, they form melody. You lean back in your imaginary control chair, eyelids heavy, and feel the faint rumble of the telescope's motors through the floor. Outside, the sky is still velvet black, the stars steady and ancient. Somewhere, 3I/ATLAS is tumbling, sunlight scattering off surfaces no one has ever seen. You imagine those surfaces, pitted, crystalline, glittering faintly green where cosmic rays have sculpted the ice into strange geometries. The thought is both humbling and oddly soothing. Someone in the chat posts a composite image, ATLAS framed against the Milky Way, a pinprick trail threading through the spiral arm like a needle stitching time. For a second, even the scientists go quiet. You realise that all the machinery, all the math, all the sleeplessness, it's really about moments like this when wonder wins. You shut your eyes and hear the hum of distant observatories blending with the soft whoosh of the fan in your room. For a heartbeat, you can almost believe the world is synchronized. Dozens of telescopes and one tired listener all breathing with the same rhythm. Out there, the comet drifts on, unaware it has become the center of a human constellation of curiosity. You blink against the glow of your monitor and feel that familiar tug, the need to zoom out, to remind yourself that 3I/ATLAS isn't just a misbehaving pixel on a screen, but a descendant of a lineage older than Earth itself. To understand the comet, you have to step backward in time, into the long, cold story of cosmic drifters. The first comets were born in the outskirts of forming stars, where gravity's reach was weak and the temperature cruel. Picture a young sun, still swaddled in dust, flinging icy debris into distant exile. Some of those frozen exiles became our Oort cloud, that vast shell of leftovers stretching halfway to the next star. Most of the comets we see today come from that region, a gravitational refugee camp filled with ancient ices and patient rocks. But ATLAS, it comes from another camp entirely, from someone else's primordial chaos. A mainstream historical fact: the Chinese were recording comets more than 2,500 years ago. Bamboo slips from 613 BCE describe guest stars with tails like smoke that bent in the wind. The Babylonians carved their sightings into clay. The Greeks debated whether comets were atmospheric or celestial, and by the Middle Ages nearly every civilization had a favourite comet to fear. Historians still argue whether these records describe specific returning comets, like Halley's, or a parade of different visitors that simply looked similar. Either way, humanity's relationship with these wanderers goes way back. We've always stared upward and tried to assign meaning to moving lights. You drift through time. Ancient priests burned incense when comets appeared, hoping to appease whatever cosmic bureaucracy governed omens. In Rome, senators wore darker togas just in case. Then, much later, Newton ruined the drama by proving comets followed laws, not moods. The Enlightenment dimmed superstition, but not fascination. The same impulse that once made people fear the sky now makes them build billion-dollar telescopes to study it. Atlas fits right into that evolution, a cosmic emissary that forces us to reevaluate everything we think we've learned. You imagine it as part of a genealogy, great-grandparent comets flung from protostars, cousins orbiting distant suns, siblings like Oumuamua and Borisov that visited briefly before vanishing into the dark. Each carries a chemical accent from its birthplace. Sodium here, cyanogen there, a touch of tholin red for flair. If comets could speak, they'd all have different dialects of ice. A quirky tidbit drifts into your mind. In 1910, when Halley's comet returned, newspapers announced that Earth would pass through its tail. Entrepreneurs sold anti-comet pills to protect people from the supposed poison gas cyanogen. Sales were excellent. Side effects included embarrassment. Somewhere, 100 years later, you can still feel that same human cocktail of dread and curiosity every time a new comet headline drops. The modern era replaced superstition with spectroscopy. Instead of prophecies, we read wavelengths. Each colour in a comet's light tells you what it's made of. Carbon, nitrogen, oxygen, maybe something exotic like methanol or formaldehyde. When scientists pointed those instruments at ATLAS, though, the story turned odd. Certain expected emission lines, particularly water, were faint or absent, while strange ones glowed brighter. It was as if the comet's recipe skipped a few local ingredients and added some from a cookbook we've never seen. Historians still argue whether such compositional oddities mean Atlas formed around a red dwarf, a binary star, or something even weirder. Each scenario paints a different picture: slow formation under dim light, chaotic bombardment, or long exposure to interstellar radiation. You can almost visualize it: the comet coalescing from alien snowflakes, while a foreign sun flickers in the distance. You picture yourself standing on an ancient steppe centuries ago, watching a comet blaze across the sky. It would have looked like a wound in the heavens, a luminous scar stretching from horizon to zenith. Now imagine that same streak as Atlas, an interstellar traveller no shaman could have predicted. The old fear returns for a heartbeat, but then you smile. Fear and wonder have always been twins. It's funny, humanity used to call comets harbingers of change. In a sense, that prophecy finally came true, not for empires or kings, but for science itself. Each time one appears, our understanding shifts. Giotto's flyby in 1986 showed us the blackened, tar-like crust of Halley's nucleus. Rosetta, landing on Comet 67P in 2014, revealed organic molecules, the building blocks of life, lurking in its dust. And now 3I/ATLAS arrives, an envoy from another sun, hinting that life's ingredients might be scattered across the galaxy like cosmic pollen. You imagine all those spacecraft and observatories as part of a long conversation with comets. The voices have changed, but the message stays the same. Tell us where we come from. Atlas doesn't answer directly. It just spins, shedding molecules that drift through vacuum like faint perfume. Somewhere in those molecules may be isotopes that differ ever so slightly from ours, a fingerprint of a foreign nursery. Detecting them could confirm that the building blocks of worlds are universal. And yet, even with all this science, a little superstition sneaks back in. You catch yourself thinking of ATLAS as a messenger, not just an object. Maybe that's unavoidable. We're pattern hunters. We read meaning into movement. Perhaps the real lineage here isn't cometry at all. It's human curiosity, passed down like genetic code from one stargazer to the next. You close your imaginary notebook, hearing the quiet tick of your desk clock echo the pulse of the comet's light curve. The centuries blur together. Ancient astrologers, Newton with his prisms, Rosetta's engineers, you with your headphones, all part of the same long watch. Out there, 3I/ATLAS drifts onward. Older than myth, younger than understanding. A reminder that history isn't a straight line but a spiral, like a comet's path looping back through the dark. You tilt your mind's telescope toward the sun, imagining its furnace glare stretching through 93 million miles of emptiness, and somewhere out there, the tiny teal speck of 3I/ATLAS daring to approach. Every comet faces this rite of passage: draw close to the star, endure the heat, and either survive gloriously or crumble into glitter. Usually that story ends in predictable drama: jets of gas, bright outbursts, maybe a breakup or two. But of course ATLAS chooses to improvise. As it swoops toward perihelion, the point nearest the sun, instruments prepare for the usual fireworks. Instead, the brightness drops. You blink, check the data again. The comet is getting darker. That's like a campfire cooling as someone piles more wood on it. The team triple checks calibration. They blame sensor drift, sunlight angle, bad luck. But the truth hardens in the numbers. The closer Atlas gets to the sun, the colder its skin seems to become. Thermal models have a hard time with that. A conventional comet's surface can heat to over 200 degrees Kelvin, enough to vaporize water ice and send plumes of gas roaring into space. Yet Atlas's thermal signature flatlines around a frigid 100. Something on or beneath its crust is blocking the sun's energy, maybe reflecting it, maybe swallowing it into some unknown endothermic process. One scientist jokes that it's using SPF 10,000. Another quietly mutters that it's acting more like a cryogenic heatsink than a snowball. Historians still argue whether early astronomers could have misread similar anomalies in comets that passed close to the sun centuries ago. In 1882, the Great September Comet stunned observers by splitting in two and brightening instead of fading. Its fragments glowed like molten pearls in daylight. The Victorians called it the Sword of Heaven. Compared with that spectacular blaze, Atlas feels like its inverse, an invisible blade made of ice and quiet rebellion. Spectrographs show oddities again. Instead of water vapor lines increasing, they weaken. In their place, faint traces of exotic molecules appear: carbon suboxide, silicon monoxide, even hints of metallic sodium fluorescing in unnatural ratios. That's chemistry more typical of a body that's been baked, then cooled, then somehow reheated by internal processes. Theorists propose everything from buried radioactive isotopes to quantum state transitions in amorphous ice. On social media, someone simply writes, "The comet is breathing in sunlight and exhaling mystery," and gains a few thousand likes. You picture standing on its surface during perihelion, if such standing were possible. The sun would be a blinding white disk 6 times brighter than on Earth, yet the ground beneath your boots would remain frost cold. Crystals might sublimate in tiny flares, then immediately refreeze, forming a glittering fog that drifts sideways like slow smoke. You'd hear nothing, of course. Sound dies in vacuum. But you'd feel vibration through your soles, a rhythmic tremor like the purring of a cat the size of a mountain. A quirky tidbit surfaces from the archives. In the 17th century, Johannes Hevelius insisted that comets emitted their own light, rather than reflecting the sun's. He was wrong, but his drawings of self-luminous comets are hauntingly apt for Atlas. If he could see this one, he might nod in vindication before updating his notebook with an all-caps "told you so." As Atlas rounds its closest approach, observers expect it to flare or shatter. Instead, it glides past intact, dimmer than before, tail faint but steady. Solar radiation pushes on it, yet its course barely changes. The orbit models groan under the weight of corrections. One researcher sighs, "It's like trying to predict the flight path of a feather in zero gravity." Another replies, "At least the feather would make sense." Historians still argue whether comets survive perihelion because of cohesive internal layers or sheer cosmic luck. Rosetta's mission showed that some nuclei are held together by fluffy dust, barely strong enough to support a handshake. By that logic, ATLAS should have crumbled long ago. But maybe interstellar comets are built different, compacted under alien pressures, fused by exotic ices that don't know how to melt. It's strange comfort to imagine a chemistry so stubborn it ignores the sun itself. You close your eyes and let the scene play in slow motion. The comet arcs around the star, a faint ember against incandescent fire. For an instant, sunlight diffracts through its coma, producing a halo of green and violet. Then it slips into shadow, unbroken, carrying with it the whispers of hydrogen, carbon, and secrets. The instruments on Earth blink with approval. Data captured, anomaly preserved. Somewhere, graduate students groan. They'll be decoding this for decades. You chuckle softly. Humanity once feared comets as omens of doom. Now we fear them as peer reviewers. Both can be merciless. Still, there's a peculiar peace in knowing that something so small can survive a star's wrath simply by obeying its own quiet physics. As Atlas drifts outward again, its temperature readings flatten even further, as though the comet learned from the encounter. You imagine it smugly polishing its icy armor, unbothered, whispering, "Nice try, son." The star that powers life on Earth just threw its best tantrum and an object the size of a mountain shrugged it off. The image lingers, an alien shard gliding through solar fire untouched, refusing to perform for us. It's not just surviving, it's redefining what survival looks like. And you, somewhere under your warm blanket, can't help but feel a little awe, a little humility, and maybe a tiny chill as if some of that impossible cold has reached you across the void. You stay with it as it recedes, half expecting the show to end, but Atlas seems to have another act prepared. The photometric data begins to flicker in ways even the most patient algorithms can't smooth out. Tiny dips, sharp flares, erratic pauses. The pattern looks less like random noise and more like a heartbeat that can't decide if it wants to stop or sprint. Someone on the observation team types fragmentation event into the shared log. Within minutes, telescopes everywhere pivot. You imagine the scene, dozens of domes turning in unison, their motors whirring against the night. A few minutes of exposure later, the first confirmation arrives. Atlas has fractured. Not exploded, not shattered like a brittle snowball, but divided neatly, as if the comet's heart had decided to practice division. One piece glows a little brighter, trailing a dust fan. The other moves slightly slower, wrapped in a faint halo of its own. At first, everyone assumes the obvious: internal stress. As a comet warms, trapped gases expand, building pressure until cracks form. Simple. But then the temperature readings roll in. They haven't risen. The internal stress shouldn't exist. Whatever broke the comet, it wasn't heat. Historians still argue whether fragmentation in earlier comets, like the Great Comet of 1843 or Comet Shoemaker-Levy 9, was purely mechanical or partly magnetic. With a TLAS, the question returns with a vengeance. The fragments behave like reluctant siblings, moving apart just enough to be distinct, yet somehow maintaining a shared rhythm. Their rotational periods sync, wobbling together as if connected by invisible string. Scientists start referring to them as A and B, though a few poetic souls insist on north and south. Someone even names them after twin mythological figures before the team lead vetoes it for professionalism. The universe is hard to catalogue when you're secretly sentimental. Spectral data adds to the confusion. The smaller fragment B shows a surprising chemical spike, a brief surge of hydrogen cyanide followed by silence. A remains steady, though its coma glows with a faint violet sheen that no one can explain. That colour usually means ionized magnesium, but the ratios are wrong. One researcher writes in the notes, maybe it's magnesium having an identity crisis. The line survives peer review intact. You picture standing between the two halves as they drift apart, a slow-motion farewell unfolding at 30 kilometers per second. The space between them fills with glinting debris, shards of ice reflecting sunlight like sequins. If you could scoop one up, you'd hold a frozen relic older than our sun, a fragment of something once solid in a different star's nursery. But the moment you touched it, it would hiss into vapor, as ephemeral as memory. A mainstream historical fact surfaces as you imagine that. When Comet Shoemaker-Levy 9 broke apart in 1992, its fragments later slammed into Jupiter, releasing more energy than 1 million nuclear bombs. For weeks, scientists watched dark bruises appear on the gas giant's clouds, proof that even small objects could wield apocalyptic power. Historians still argue whether that event marked the birth of modern planetary defense initiatives. Compared to that violent spectacle, ATLAS's fracture feels gentle, almost elegant. But elegance doesn't mean simplicity. The orbital projections for both pieces quickly diverge from prediction. A seems to accelerate slightly as if pushed by something internal. B decelerates. Together, their combined mass and motion no longer add up to the original object's momentum. That violates every comforting rule of conservation of energy you've ever learned. Someone jokes that the universe is cooking its books again. A quirky tidbit slides into your thoughts. In the early 20th century, a few astronomers proposed that comets were not single bodies at all, but aggregates of icy microplanetoids, swarms bound by mutual gravity. Atlas's neat self-division almost makes that sound plausible again. Maybe what we thought was a solid nucleus was actually two travellers loosely holding hands for millions of years, finally deciding to let go. Romantic in a very frozen way. By week's end, telescopes confirm that the main body has dimmed further, while the smaller fragment brightens unpredictably. The speculation carousel spins faster. Could the smaller piece be hollow, exposing fresh ices? Could it contain pockets of volatile compounds untouched since interstellar flight began? Someone half-jokingly calls it the comet's brain. The joke sticks because, well, no one can rule it out. Historians still argue whether humanity's obsession with personifying celestial events, naming them, assigning them intent, helps or hinders understanding. You suspect it does both. The labels we choose, the stories we tell, are scaffolding for comprehension. Without them, we drown in data with no meaning attached. You imagine the two halves drifting apart in slow elegance, each glowing faintly as sunlight catches their ragged edges. The dust between them fans out into a thin, twisting bridge that will, for a short while, reflect enough light to be seen even by modest backyard telescopes. Somewhere, a kid in rural India will capture it with a smartphone lens and post it online, calling it two souls dancing. The professionals will call it fragmentation debris, but the sentiment will feel the same. Night after night, the twins keep their synchronized wobble, like dancers turning under a silent rhythm. If the universe does have choreography, ATLAS seems to know the steps. You lean back, eyes half closed, and let the thoughts settle. A comet splitting not from weakness, but from some quiet internal choice. A transformation rather than a death. For the first time, you feel that Atlas might not just be passing through our system, it's performing something. A kind of cosmic ballet meant to remind us that even breaking apart can look beautiful if you do it with enough grace. You settle deeper into your chair, imagining yourself shrinking down through the data stream until you're floating amid the faint particles trailing behind 3 I/ATLAS. They're not just dust, they're little relics, microcrystals, microscopic archives of other suns. When astronomers talk about cometary dust, it sounds dull, like housekeeping. But to be here, drifting beside these grains, is to hover among stories frozen in silence. You picture one, smaller than a speck of smoke, tumbling lazily. It left the comet's fractured body hours ago, now spinning alone through the void. Sunlight hits it and flashes a prismatic glint before moving on. Instruments on Earth and orbiting spacecraft, infrared detectors, radio arrays, polarimeters, pick up whispers from countless grains just like it. Their faint emissions carry signatures of the elements that built them. It's astonishing what you can learn from something too small to see. Each particle is a time capsule. Some hold ratios of deuterium to hydrogen that don't match any known solar value. Others show traces of crystalline silicates, which only form at high temperatures. How could such materials exist in something that lived most of its life near absolute zero? The contradiction burns deliciously. You can almost hear the theoreticians muttering through their teeth. A mainstream historical fact. In 1986, when ESA's Giotto probe flew through Halley's Comet, its dust analyzer recorded the first in situ sample of cometary grains. Those fragments turned out to be more complex than anyone expected. Carbon-rich, peppered with amino acid precursors. Historians still argue whether that mission marked the beginning of astrochemistry's obsession with life's building blocks. What Giotto started, Rosetta and now Atlas continue, turning dust into confession. The spectra from ATLAS's debris are baffling. There's the usual carbon and oxygen, sure, but also faint hints of phosphorus compounds and a whisper of nitrogen in ratios never before catalogued. One line even matches a laboratory signature for phosphine hydrate, a molecule that shouldn't survive interstellar radiation without breaking down. Yet here it is, glowing faintly across light years. Someone on the research call mutters, either our instruments are haunted or the universe is creative. A quirky tidbit floats through memory. In the 1960s, a fringe physicist claimed comet tails might be biological effluvia, the exhalations of giant space organisms feeding on starlight. His paper, quickly retracted, still circulates online whenever a new comet behaves oddly. You grin at the absurdity, but can't help noticing how poetic the idea sounds now. Watching Atlas breathe gas that looks suspiciously alive, the dust trails continue to whisper. Using radar backscatter, scientists map their distribution and find that the grains don't spread uniformly. They cluster, forming faint ribbons of density that twist and pulse. Some call it turbulence from solar wind, others suspect electrostatic clumping. Either way, the pattern looks deliberate, like Morse code written in ice. You zoom in, half expecting to read something. The message, if there is one, remains beautifully undecipherable. Historians still argue whether earlier missions, like Stardust's return capsule in 2006, captured genuine interstellar grains or mere solar debris. Stardust samples contained glycine, the simplest amino acid, sparking headlines about life's seeds from comets. Atlas's dust, if confirmed interstellar, could push that argument further. Maybe life's ingredients wander between star systems the way dandelion seeds ride the wind. Each comet that passes could be planting possibilities. You imagine the scene within Atlas's debris field. Thousands of grains, each reflecting sunlight, each carrying the scent of another chemistry. They move slowly enough that you could chase one with your gloved hand. You'd watch it shimmer and realize you're seeing matter older than your planet's crust. That realization always shrinks you, in a good way. The kind of smallness that makes you breathe easier. Observatories on Earth capture polarimetric data. Light scattered by those grains reveals their shapes. To everyone's shock, many appear hexagonal, not the irregular dust clumps expected. That geometry implies crystallization under unusual conditions, perhaps rapid cooling in a magnetic field. They look engineered, someone says half seriously in a Slack channel. By whom? Water molecules, comes the reply. Jokes are oxygen in science. They keep panic from sounding like ore. You can almost taste the static hum of data transfer, the clatter of keys as analysts compare results. Each new plot deepens the mystery instead of solving it. The dust behaves as if it remembers something, as if it's been prearranged to react in ways that make us notice. You remind yourself that coincidence is the universe's favourite sense of humour. Another historical fragment surfaces. The ancient Greek philosopher Anaxagoras believed life spread through space by seeds, drifting between worlds, a theory he called panspermia. Centuries later, it's back in peer-reviewed journals with better math. Historians still argue whether he was lucky, prophetic, or both. If he were here tonight, he'd probably nod at ATLAS's dust and say, "Told you." Your eyes wander across the night outside your window. The stars seem closer somehow, as if the comet's passing pulled everything inward for inspection. Somewhere up there, grains from ATLAS are crossing the orbits of Mars and Earth, harmless but holy in their way. In a few weeks they'll scatter and fade, but some might drift long enough to be caught by Earth's gravity, burning briefly as meteors too faint to notice. You wonder how many times we've watched falling stars that were actually whispers from other suns. You smile at the thought. Even in its disintegration, Atlas leaves us presents, tiny chemical puzzles that remind us the universe is built from the same dust that covers our shelves, our streets, our lungs. It's almost comforting, the cosmos shedding itself like skin, letting us study the flakes. You inhale and exhale slowly, matching the comet's invisible rhythm. Somewhere beyond the solar wind, a billion more fragments spin, carrying secrets no microscope will ever read. And you realise that maybe that's the point, not to solve everything, but to keep following the trail, grain by grain, until curiosity itself becomes the destination. You're still floating in that trail of cosmic dust when your imagination nudges you sideways through time, into a softer thought. How might this teal, reverse-tailed wanderer have looked to people before telescopes and chemistry? You can almost feel the shift. The hum of hard data fades, replaced by drum beats and whispered awe. Picture a field somewhere along the Nile 3,000 years ago. The air is thick with night warmth, reeds hissing softly in the breeze. Farmers glance up between torchlit rows and see a new star with a ghostly plume bending the wrong way. They don't have words like spectrograph or perihelion, they have myth. A scribe scratches a quick note onto a piece of pottery. A torch star rises, pointing toward the gods. Historians still argue whether that inscription described a comet, a supernova, or wishful thinking after too much beer. Now imagine the same sky from the Yucatan. A priest astronomer of the classic Maya marks the streak on a bark paper codex, lining it up with Venus. Certain the omen means the maize will grow thin this season. Far away in China, court astrologers record a broom star that swept backward, perhaps not unlike 3I/ATLAS with its upstream tail. You can almost hear them debating how many sacrifices it would take to make heaven stop sweeping so ominously. A mainstream historical fact floats in. In 1066, a bright comet, Halley's, blazed over England just before the Battle of Hastings. Chroniclers drew it with a trail like fire and wrote, "A fearful star appeared." William the Conqueror used it as proof of destiny. His enemies called it a curse. Historians still argue whether the comet's appearance truly swayed morale, or if it simply made good propaganda. Either way, comets and power have always shared a suspiciously cozy relationship. You glance back at ATLAS's eerie image and grin. If medieval kings saw this one bending its tail sunward, they might have locked up their astrologers for insubordination. Even now, scrolling through social feeds, you catch that same ancient reflex. Half the posts whisper apocalypse, the other half declare cosmic awakening. Civilization changes costumes, but superstition just updates its hashtags. A quirky tidbit. In 1910, when Earth passed through Halley's tail, one Parisian cabaret offered comet cocktails, green absinthe with a flaming sugar cube on top. Patrons toasted to survival. No one perished, but the hangovers were historically confirmed. You chuckle, thinking humanity copes with cosmic anxiety, mainly by inventing better drink menus. Back to your imaginary field. A lone observer, maybe a shepherd, maybe a dreamer, tilts his head. To him, that glowing streak isn't doom or data, it's beauty that refuses to be categorized. He doesn't write it down, he just remembers it long enough to tell his grandchildren. Thousands of years later, a satellite bearing the same curiosity catches ATLAS's faint signal and translates it into numbers. Different language, same wonder. Historians still argue whether our ancestors' awe was superstition or the first spark of science. Maybe both. The line between magic and measurement was always thin. Both require believing that the universe is speaking to you if only you learn its grammar. Atlas's strange tail and cold glow are just new grammar lessons, verbs we haven't conjugated yet. You think of the great comet of 1811, bright enough to cast shadows at night. Napoleon's soldiers marched beneath it. British poets wrote about it. American farmers swore their grapes grew sweeter that year. 2 centuries later, Atlas passes with less spectacle but more mystery, a quieter revolution. Perhaps we've traded brightness for depth. You imagine future historians scrolling through our data archives, seeing the debates, the jokes, the memes, the late-night Slack threads. They'll smile and say, the early 21st century, still trying to make sense of wonder with spreadsheets. And they'll be right. Every age translates astonishment into its own dialect. Outside your window, modern city light smothers most of the stars, yet you can still sense the sky pressing down with infinite patience. Somewhere beyond that orange haze, ATLAS moves on, indifferent to our metaphors. Still, you can't resist giving it one, a mirror held up to every generation that ever looked skyward and felt small. Maybe that's why we keep cataloguing these wanderers. They remind us that being temporary doesn't mean being meaningless. Each comet's passage says the same quiet sentence. You were here, you noticed, that's enough. You breathe in, exhale slowly. The fan hum replaces the wind over the Nile. The click of your keyboard replaces the scratching stylus of an ancient scribe. The continuum feels seamless. The comet continues its arc, gathering history the way its tail gathers sunlight. Each era leaving a thin layer of interpretation, glowing faintly, then drifting on. You let the ancient echoes fade and the hum of modern instruments creeps back in. The comet's tail, its mysterious chemistry, its heartbeat-like flicker, all of it boils down to a single tantalizing problem. Why? Theories multiply faster than the coffee supply at the observatory is trying to solve it. Everyone wants the headline, "Comet defies physics explained," but the truth remains slippery, curling away like vapor in sunlight. The big question on everyone's lips, what's causing that impossible tail? The sun's radiation pressure alone can't reverse it. Magnetic interactions can bend a plasma tail, yes, but not twist it inward. So, the explanations start branching like neural pathways. The sensible ones talk about electromagnetic recoil. Maybe the comet's ions are caught in a fluctuating region of the heliospheric current sheet, where the sun's magnetic field flips polarity. That's plausible, elegant, and very dull. The wilder idea comes from a few physicists whispering about quantum ice. It sounds like science fiction, and to be fair, it sort of is. But the theory suggests that under extreme cosmic radiation, some ices can form metastable lattices that trap energy. When released, they could generate local electromagnetic pulses, nudging particles around. Historians still argue whether comets could even sustain such exotic structures without collapsing into dust. But in the late-night corners of astrophysics Slack channels, no speculation is too far-fetched. And then, of course, comes the crowd favourite, magnetic mirroring. Some models propose that ATLAS's charged particles are being deflected by solar magnetic loops, creating the illusion of an inverted tail. Think of it as a cosmic hall of mirrors, light bending, particles dancing, observers squinting. It fits some data points, not others. You can almost hear the sighs from conference rooms worldwide. Elegant hypothesis, inconvenient reality. A mainstream historical fact bubbles up from your sleepy brain. In 1959, astronomer Ludwig Biermann proposed that comet tails were shaped not by light, but by a stream of charged particles from the sun, the solar wind. That single insight reshaped space science. Historians still argue whether Biermann's idea, radical at the time, inspired the eventual discovery of the solar wind itself. Now, decades later, ATLAS seems to be asking us to rewrite that chapter again. Maybe the rules we thought we mastered are just local customs. You pull up a simulated model, lines of light representing plasma flows and field vectors. It's hypnotic, like watching a screensaver built by Einstein and Escher. The comet sits at the centre, threads of ionized gas streaming around it in geometric spirals. Occasionally the whole structure flips, tail swinging sunward for a few hours before relaxing again. If that's electromagnetic recoil, it's doing ballet. And because humans are humans, the internet immediately takes the quantum ice idea and runs with it. Forums fill with talk of negative mass plasma and self-shielding fields. A few posts hint that maybe ATLAS isn't reacting to the sun at all, but to something else, some external signal. You roll your eyes and sip your imaginary tea. Still, you can't help admiring the creativity. Where scientists see anomalies, others see invitations. A quirky tidbit. In the 1970s, a group of Soviet astrophysicists published a paper suggesting comets might generate their own magnetic fields through frictional plasma interactions, a kind of mini-magnetosphere. It was ridiculed then, quietly resurrected now. If Atlas really is shielding itself, it would make those old papers look prophetic. You can almost picture some retired physicist somewhere smirking into his samovar. As the debates heat up, something remarkable happens. Collaboration. Teams that rarely share data start pooling it freely, desperate to decode the phenomenon before the comet fades. Machine learning algorithms analyze terabytes of light curves, searching for correlations. One pattern emerges, a periodic oscillation in the tail's direction every 11.2 hours, matching the comet's rotation period almost exactly. That's the first hint of self-coupling. Whatever drives the tail is tied to the nucleus's own spin. Historians still argue whether science advances through competition or cooperation. Here, it's both. Rival labs race to interpret the data while secretly cheering each other on. It's almost wholesome, in a nerdy way. Late-night Zoom calls buzz with laughter and debate. Someone coins the phrase solar wind tango, and it sticks. By now, ATLAS has become a celebrity. News outlets love the mystery. Talk shows crack jokes about comet physics rebelling against authority. The general public might not understand magnetic reconnection, but everyone loves a cosmic rebel. And in the quiet corners of observatories, scientists quietly appreciate that, for once, the world is paying attention to something truly weird for the right reasons. You step away from your imaginary screen and stretch. The comet's image lingers in your mind, that faint teal arc refusing to conform. You think of how fragile it must be, how utterly insignificant by mass, yet capable of bending our understanding of an entire solar system. There's something poetic in that, smallness that teaches enormity. As your breathing slows, you let one last idea drift in. Maybe the reason we're drawn to explanations, electromagnetic recoil, quantum ice, magnetic mirroring, isn't just curiosity. Maybe we want the universe to make sense because that means we belong here. But comets like Atlas remind us that sense is optional. Beauty works fine without it. You look up at your ceiling, the lights soft and gold, and pretend it's the solar wind rushing past. Somewhere out there, the impossible tail flickers again, defying logic, daring us to follow, writing equations in teal smoke that we'll spend generations trying to read. You can almost smell the coffee and cold pizza of discovery nights, the strange perfume of obsession that fills every lab when data starts to contradict itself. 3I/ATLAS has moved far enough from the sun now that its glow should be fading quietly, decaying by predictable logarithmic steps. Instead, the readings oscillate like mood swings. Each telescope pass, the numbers tell a different story, and the storylines collide like gossip across galaxies. The line between data and myth gets thin. What starts as precision soon becomes folklore. A graduate student posts a GIF of the comet's flickering brightness and captions it, "Heartbeat of a Wanderer." Within hours, that phrase turns into a hashtag, then a slogan, then merch. Science journalists pick it up, eager for poetry in the void. Somewhere, a weary astronomer mutters, "We're losing control of the narrative," while their PR department grins. And maybe that's the natural cycle. Each time the universe hands us something weird, we turn it into story first and math later. Oumuamua became the alien probe, Borisov became the perfect comet, now Atlas, with its two bodies and impossible tail, becomes the comet that learned to dance. Historians still argue whether storytelling helps or hinders scientific truth, but the truth is, you can't stop people from making meaning out of mystery. It's our default operating system. Inside the observatories, though, meaning has to wait. The two fragments, A and B, continue their uneven waltz, their brightness curves crossing like overlapping heartbeats. The data sets are a mess. One brightens while the other dims, sometimes swapping roles as though communicating through light. They're gossiping, one tired researcher says during a 4 a.m. call, and everyone laughs just enough to stay awake. A mainstream historical fact floats to the surface. When Tycho Brahe observed the Great Comet of 1577, he proved it moved beyond Earth's atmosphere, demolishing the Aristotelian idea that comets were weather. Historians still argue whether that discovery marked the birth of modern astronomy, or just another lucky measurement made by an obsessive with good eyesight. Either way, it's comforting to think that 400 years later, we're still arguing about what the sky is made of, only now with better snacks. You scroll through forums and comment threads, the spectrum of reactions is pure 21st century. Half the posts scream alien engine confirmed, half beg everyone to calm down, and somewhere in the middle a few patient experts are trying to explain plasma coupling in 280 characters. Someone uploads a meme of two icy comets dancing to Stayin' Alive. The caption, a TLASA and B dropping their breakup album. Science communication, modern style. A quirky tidbit. The astronomer Johannes Kepler once proposed that comets were exhalations of the sun, breaths of divine fire shaped by the music of the spheres. If only he had Twitter, you think he'd fit right in? His mix of physics and poetry would trend instantly. You smile, realizing that even back then, the line between observation and imagination blurred delightfully. In quieter corners of academia, though, debates burn hotter. Some researchers claim Atlas proves that our understanding of non-gravitational forces on small bodies is incomplete. Others insist it's all statistical noise. Papers begin flying across the archive like snowflakes, each contradicting the last. Historians will have fun with this one, a professor sighs during a seminar, and they will. Every messy controversy leaves breadcrumbs for future curiosity. What fascinates you is how quickly science starts to look like art when certainty dissolves. You picture two teams, one in Japan, one in Chile, each modelling the same data, yet drawing completely different diagrams. Both might be wrong, but both are beautiful. It's almost like Atlas has turned the whole planet into a brainstorming session about reality itself. Late one night, a live stream catches something strange. Fragment B brightens suddenly, then emits a burst of faint radio static. Not a signal, exactly, more like a sigh. The noise matches the frequency of hydrogen transitions, but shifted by an odd amount. Instruments record it. Analysts argue whether it's interference from solar activity or an actual emission from the comet. For a week, headlines scream, "Mysterious comet radio burst." Before the excitement settles into another line of data, still the sound lingers in your imagination. You replay it mentally, a whisper across millions of kilometers, and feel that tickle of gooseflesh that only good mysteries cause. Historians still argue whether such spikes matter scientifically or symbolically. You suspect both. Every unexplained signal becomes a mirror reflecting what we want the universe to be. Some people hear static, others hear possibility. The difference is mostly about heart rate. Meanwhile, the cultural wave crests. An indie musician releases an ambient album titled Songs for a Two-Headed Comet. A perfume company markets Atlas Mist, promising the scent of interstellar ice. Even a streaming documentary begins filming, full of slow zooms and soft synth music. You watch the trailer and chuckle. It's nonsense, but it's sincere nonsense. Wonder sells, and at least this time it's honest wonder. You glance at your notes, a column of numbers, a cluster of sketches, and between them a doodle you don't remember drawing. Two spirals entwined, like the fragments themselves. Maybe myth-making isn't failure, but adaptation. Facts alone can't hold the whole shape of ore. They need metaphor scaffolding to stay upright. The observatories keep humming, the comet keeps fading, and the debate keeps glowing. You realise you're part of the pattern now, a storyteller orbiting a story. Atlas entered the system as an alien body and left as a symbol of human restlessness. Every telescope, every keyboard, every late-night argument becomes its extended tail. Outside, dawn bleeds grey over your city. You can't see any stars, but that's fine. They're all still there, waiting for nightfall. Somewhere far beyond the sun's warmth, two icy fragments drift apart, still linked by invisible equations and by every rumour we've wrapped around them. The data may fade, but the myth is permanent. You exhale, a quiet laugh escaping. The universe keeps sending riddles, we keep replying with stories. Maybe that's the real conversation. You return to the stream one dusky evening, expecting routine numbers in gentle decline, but Atlas refuses to coast. The orbit trackers light up like warning panels. Its path, once stable, is curving where no external force should exist. The math stutters. Gravity, that old and faithful metronome, seems to be missing a beat. The trajectory had been clear for months, an outbound hyperbola that would carry the comet back to the stars, past Neptune, into the long frost between suns. But new data shows a kink. A small one, yes. 0.5 degree at first, then 1, then 2. Enough to make every orbital plot curl like paper near flame. It isn't a simple deflection. It's as if Atlas has changed its own mind. At first, astronomers blame the usual suspects, asymmetric jets of gas acting like thrusters. That's the standard explanation whenever a comet seems to maneuver. But spectrographs show no increase in outgassing. Its coma is shrinking, not flaring. The thrust, if it exists, comes from silence. One team proposes that internal crystallization of amorphous ice could release gas pockets in bursts. Another suggests microfractures aligning with rotation, creating subtle torque. It all sounds rational, until someone points out that the direction of the change doesn't match any known vent orientation. A mainstream historical fact. When the spacecraft Pioneer 10 and 11 drifted outward in the 1990s, they too deviated slightly from predicted paths. For years, the Pioneer anomaly haunted physics conferences until thermal recoil from their own heat emissions was found guilty. Historians still argue whether that explanation truly closed the case or simply saved face. Now, Atlas seems to be resurrecting that ghost, an uncooperative traveller shrugging off calculation. As orbital models diverge, people begin whispering words they shouldn't. Propulsion, control, self-correction. Not publicly, of course. The official statements stay cautious. Non-gravitational accelerations under investigation. But you can feel the tremor under the language, the way caution always quivers next to imagination. You picture the comet tumbling through space, its two fragments still in loose choreography, sunlight flashing off their rough sides. If you slow time enough, you'd see tiny puffs of vapor, no larger than campfire smoke erupting from specific points, then stopping abruptly, as if coordinated. The pattern repeats every few rotations. Coincidence, perhaps, but tidy coincidence makes scientists twitch. The numbers say that over a span of 12 days, Atlas has nudged its trajectory enough that its outbound path will no longer pass near Saturn's orbit, but cut slightly above it, stealing a few million kilometers of altitude. That kind of adjustment would require an impulse equivalent to the firing of a small rocket, which of course comets don't have. You remember reading about the Deep Impact mission in 2005, when NASA deliberately slammed a probe into a comet to study its interior. The blast changed the comet's spin by a measurable fraction, a reminder that even small pushes matter in deep space. Historians still argue whether that experiment taught us more about comets or about our appetite for spectacle. In Atlas's case, there's no impactor, unless it struck something invisible. A quirky tidbit surfaces. During the Cold War, a rumour spread among UFO enthusiasts that certain comets occasionally executed course corrections because they were, in fact, alien observation platforms disguised as natural bodies. The claim came from misread radar data on Comet Enki. Completely false, of course, but now, watching Atlas twist its arc, you understand how myths like that start. All it takes is a few stubborn decimals refusing to obey. Meanwhile, the world's major observatories coordinate a tracking campaign so intense it borders on obsession. Even radio telescopes join in, bouncing faint pings off the comet's tail plasma to map its motion. The return signals come back ever so slightly Doppler shifted, confirming acceleration but offering no clue why. Either we've miscalculated the universe, one astronomer sighs, or the comet has better engines than we do. Historians still argue whether humanity's instinct to anthropomorphize anomalies is curiosity or vanity. You suspect it's both. We want the cosmos to mirror us, to have intention, to make choices. Yet there's something humbling in the idea that a frozen lump of alien ice might simply follow physics we haven't written yet. The debate spills beyond academia. Think pieces flood the internet. Is a TLAS alive when objects rebel? Should we rethink motion? Some are nonsense, some lyrical, all part of the same modern ritual, turning uncertainty into conversation. A philosopher posts that perhaps the comet is teaching us what freedom looks like, movement without permission. It trends for a day. You lean closer to your imaginary display. The latest orbital overlay shows Atlas's path glowing in teal, diverging gracefully from prediction. It's not violent, not erratic, just confident, like a bird adjusting its wings to catch a better current. Outward it goes, past the realm of ice giants, toward the interstellar night from which it came. Only now it carries a tiny asymmetry, a fingerprint of choice etched into mathematics. Maybe there's no propulsion at all. Maybe the fragment's uneven evaporation simply acts as nature's version of steering. Or maybe the sun's magnetic fields are twisting the plasma around it, creating feedback forces no one's modelled yet. The honest answer is, we don't know. And that admission, whispered into the void, feels less like defeat and more like reverence. A single photon leaves the comet right now, bounces across billions of kilometres and finds a telescope mirror. It lands, releases its energy, and tells us, quietly, the story's still changing. You smile at that, because this is what science really is, a love affair with things that won't sit still long enough to be understood. The fan in your room hums like distant engines, though you know it's just plastic blades pushing air. Still, for a heartbeat, you let the illusion stay. Out there, a shard of alien ice may be steering itself into the dark, humming its own trajectory, free of every orbit we ever imagined for it. By now, every telescope on Earth has handed in its homework, and the numbers all agree on one uncomfortable truth. 3I/ATLAS isn't where it's supposed to be. When equations start failing, imaginations fill the gaps, and the oldest, loudest question re-emerges from the attic. Could it be artificial? The phrase first appears buried in an online comment thread, a casual throwaway, "What if it's not a comet at all?" Within hours, it mutates into headlines. A week later, you can't scroll without stumbling into glossy thumbnails screaming "alien tech confirmed," complete with stock photos of sources. You sigh. History repeats, but now it's click monetized. Inside the real research world, the tone stays careful. No one says spaceship out loud, but everyone remembers the Oumuamua debacle of 2017. That long, shiny rock had barely left before half the planet decided it was an alien probe. A few respected scientists toyed with the idea too. It wasn't entirely crazy, just extremely unsupported. Historians still argue whether the public frenzy around Oumuamua helped or harmed scientific openness. You'd think we'd have learned restraint. Then Atlas twitches its orbit and all bets are off. The facts are mundane yet deliciously ambiguous. The acceleration is steady, not random. The fragments pulse in brightness with near-perfect periodicity. There's even that faint radio hiss detected weeks ago, probably solar interaction, but it sounds intentional when amplified through curiosity. Humans are wired to mistake rhythm for language. A mainstream historical fact surfaces. In 1920, Nikola Tesla claimed to have intercepted repeating signals from Mars. They were later traced to natural cosmic radio bursts, but the idea of a cosmic conversation never really died. Historians still argue whether Tesla's misunderstanding birthed radio astronomy or modern conspiracy theory. Watching Atlas, you sense both legacies alive and well. Then come the fringe theories, blooming like frost on a window. One claims the two fragments are part of a binary craft performing controlled separation maneuvers to shed momentum before escape. Another insists the tail's inversion is an ion exhaust signature. A third, more baroque version argues that ATLAS is a message delivery system, an ancient beacon passing through countless civilizations, each adding data layers to its ice like graffiti on a cosmic subway car. You can't help smirking, it's absurd but oddly poetic. Meanwhile, the sober voices stay grounded. They remind everyone that exotic chemistry can mimic intention, that symmetry doesn't equal design. One astronomer publishes a paper titled "No Evidence of Alien Propulsion in 3I/ATLAS," which immediately trends as evidence of alien propulsion in 3I/ATLAS. The internet's selective hearing remains undefeated. A quirky tidbit. In 1967, when Jocelyn Bell Burnell discovered the first pulsar, a radio beacon pulsing with eerie regularity. She jokingly labelled it LGM1 for Little Green Men. For a few weeks, Cambridge seriously considered extraterrestrial intelligence before realising it was a neutron star. Atlas's repeating light curve carries that same mischievous déjà vu. You almost want to nickname it LGM Comet, if only for nostalgia. You imagine the conversations unfolding behind closed doors at observatories. Veteran astronomers remind students to breathe, to keep their skepticism sharp. Extraordinary claims require extraordinary coffee, one jokes, pouring another cup. They analyse dust spectra, magnetic models, thermal inertia, all the boring things that keep the world sane. Yet, in quieter moments, you know they glance at the data and feel the same forbidden flutter you do. What if? The notion of alien craft is intoxicating not because it's likely, but because it flatters us. It suggests we're interesting enough to visit. Historians still argue whether humanity's search for extraterrestrial life is driven more by curiosity or loneliness. Watching Atlas, you suspect the line between the two doesn't exist. You scroll through yet another late-night live stream. A charismatic podcast host leans toward the camera, whispering that the Comets' maneuvers match theoretical patterns of light sail deceleration. You chuckle. They're quoting real physics out of context, but it sounds convincing under moody lighting. The chat floods with speculation, hearts, and flame emojis. Somewhere, an actual astrophysicist facepalms so hard the sound echoes through academia. Still, you can't fully dismiss the wonder. Even if it's natural, Atlas demonstrates that the universe already builds machines more complex than our imagination. Heat engines of ice, timepieces of spin, and sunlight. Whether crafted by intelligence or accident, the result is artistry. You lean back and think of another historical echo. In 1977, the Big Ear radio telescope caught a 72-second narrowband signal from deep space. The astronomer who found it scrawled "wow" in red ink beside the printout. Historians still argue whether that exclamation was justified. With Atlas, every new data point feels like a quiet modern echo of that word. Wow, indeed. As the comet drifts outward, fading in visible light, the rumours crescendo. Conspiracy forums declare it's turning off its engines. Mainstream science quietly schedules more observations. The truth, as usual, hides in the blur between excitement and evidence. You feel oddly calm about it. If it were artificial, what then? The sky wouldn't suddenly fill with ships. It would just mean the universe had been busy while we were busy arguing. The hum of your fan deepens, steady as the comet's pulse. You picture Atlas tumbling in slow motion, its twin shards glinting, one bright, one shy, as though exchanging coded goodbyes. Maybe it's not an alien messenger at all. Maybe it's a teacher, showing us how to balance awe and doubt without letting either burn away. You smile, whispering into the dark, "Nice work, whatever you are." The chatter doesn't fade, it simply changes wavelength. As 3I/ATLAS drifts beyond the reach of optical telescopes, radio observatories pick up the chase. They call it listening in the static, a romantic euphemism for staring at a graph full of noise until your brain starts inventing patterns. Yet that's where the next surprise waits. The first hint arrives from the venerable Arecibo archives. Well, what remains of them after the collapse? A team combing through legacy data for calibration pings notices a faint echo that shouldn't be there, a whisper riding the solar wind background. It's not music, not Morse code, just a thin oscillation in the 1420 MHz band, the frequency of neutral hydrogen. Hydrogen is the most boring element imaginable, which is exactly why every SETI program on Earth uses it as the cosmic meeting place. When something hums there, even faintly, people lean in. The new observatories confirm it. Meerkat in South Africa, FAST in China, even a repurposed dish in Australia, all record the same low-amplitude flutter when the comet's coordinates slide across their beam. Statistically, it could be coincidence. Emotionally, it feels like gooseflesh. A mainstream historical fact surfaces. In 1974, scientists beamed the first deliberate message to the stars from Arecibo toward the globular cluster M13, a digital postcard describing humanity in binary code. Historians still argue whether it was communication or performance art. Half a century later, our descendants are still listening for a reply, and tonight that habit pays a dividend in déjà vu. The spectral analysts get to work. Most call it a natural modulation of plasma waves in the comet's ion tail, solar wind buffeting ionized gas at resonant frequencies. A few mavericks point out that the modulation looks too tidy. It repeats roughly every 42 seconds, a rhythm precise enough to make even hardened skeptics frown. Solar wind doesn't count to 42, one of them says quietly in the control room. Someone else mutters, maybe it's a joke, 42 is always the answer. The laughter is nervous but necessary. The debate spreads fast. On the SETI Slack channel, a thread titled Atlas Signal Balloons to Thousands of Messages half insist it's plasma interference, half flirt with the unmentionable. You can almost hear the keyboards clicking like rainfall. The phrase structured noise becomes the new mantra, a safe way to say, we don't know. A quirky tidbit. In 1960, when Frank Drake ran the first modern SETI experiment at Green Bank, the telescope accidentally locked onto a passing military radar. For 5 thrilling minutes, the team believed they'd found extraterrestrial life. Drake later joked that those were the happiest and most embarrassing minutes of my career. Atlas's whisper has the same flavour, thrill seasoned with dread. The signal stays inconsistent. Sometimes it vanishes for hours, then returns stronger. Sometimes it shifts upward by a few hertz, as if Doppler shifting in perfect sync with the comet's spin. Correlation doesn't prove causation, but it does pour fuel on imagination's campfire. Historians still argue whether curiosity or paranoia drives faster science. Tonight, both engines roar. To cross-check, a few clever amateurs repurpose old satellite dishes in their backyards. One engineer in Finland rigs his feed horn to a homemade cryogenic preamp and proudly posts a screenshot showing the same faint peak. Within days, hundreds of others try and fail to reproduce it. The thread devolves into good-natured chaos, signal, artifact, wishful thinking, repeat. But for a brief shimmering week, the whole planet seems united in listening. You imagine leaning against one of those cold parabolic dishes, the wind cutting through your jacket, the sky pouring radio waves invisible and eternal. Somewhere above that horizon, ATLAS is already halfway to the heliopause, its twin fragments still pulsing faintly in reflected sunlight. The idea that it might also be speaking, even accidentally, makes the night feel enormous. Eventually the professionals get consensus. The signal likely comes from magnetic reconnection events in the comet's plasma sheath. In other words, nature's static. The official announcement is dry, careful, and correct. Yet you notice how few people seem disappointed. The romance of maybe lingers longer than proof ever does. Once a whisper enters human folklore, it never quite fades. A mainstream historical footnote helps you smile. When the WOW signal appeared in 1977, follow-up scans never found it again. Historians still argue whether that failure was tragedy or mercy. Some mysteries, they say, are more valuable unsolved. Atlas seems destined to join that club. Still, the radio arrays keep an ear open. Data is cheap, wonder is priceless. Each night they point their dishes at the coordinates, letting cosmic noise wash over the receivers. Somewhere inside that noise the comet hums, and you swear you can almost pick out a melody. Not alien, not human, just cosmic background tuned accidentally to the key of curiosity. You close your eyes. The fan in your room drones at its steady pitch, blending with the imaginary static. It sounds like distance turned into sound, a whisper from a snowball racing toward oblivion. You know the rational explanations by heart, but for a heartbeat you let the irrational ones stay. Maybe the universe just wanted someone to listen. The hum of that imagined static lingers long after the receivers fall silent. You picture 3 I/ATLAS drifting past the outer planets now, faint as a wish, but stubbornly traceable. Beyond the range of visible light, instruments still track its motion by radio reflections. Tiny, regular, precise. The math says it's escaping, that the sun's gravity has finally lost its hold. The metaphor says something else. The universe doesn't do goodbyes, only long, slow farewells. Out past the orbit of Neptune, solar radiation is thin as candlelight. Here, sunlight takes 6 hours to arrive, and its warmth could not melt butter. Comets passing this far normally freeze into stillness, their trails collapsing into ghostly arcs of dust. But Atlas, still bright in ultraviolet, shows faint jets flickering from both fragments as though breathing under ice. Each pulse nudges it outward a little faster, Astrodynamicists stare at their models. The outbound velocity keeps climbing by millimeters per second. Not impressive in human terms, but in space that's like finding a heartbeat in a statue. The consensus becomes cautious poetry. Non-gravitational acceleration consistent with continued activity. It means the comet refuses to nap. A mainstream historical fact drifts through your mind. When Voyager 1 crossed the heliopause in 2012, it became the first human craft to leave the sun's magnetic bubble. Historians still argue whether that milestone marked the end of exploration or the beginning of something new. Watching Atlas approach the same frontier, you feel the parallel. One mechanical messenger built by us, one natural envoy built by somewhere else, both sliding toward interstellar quiet. Past Saturn, the solar wind weakens into slow sighs. The heliospheric boundary looms ahead, that invisible skin where the sun's influence fades and the galaxy's own magnetic fields begin. Data from probes shows that region crackling with charged particles, a sort of cosmic surf. Atlas is heading straight for it, trailing dust like phosphorescent foam. Radio arrays catch one last trick before it slips beyond their reach. The faint hydrogen line flutter detected weeks ago grows fainter, but instead of fading smoothly, it decays in deliberate steps, stair-like, quantized, as if the comet is exhaling in measured breaths. The graphs look oddly musical. Resonant plasma decay, says the official note. A farewell song, murmurs the night shift technician. Both statements can be true. A quirky tidbit. When the Galileo spacecraft plunged into Jupiter in 2003, mission controllers broadcast Beethoven's Ninth toward it in farewell, reasoning that if anyone out there was listening, joy was a decent introduction. You can imagine some future probe doing the same for ATLBS. A little music tossed into the dark, one melody chasing another. Historians still argue whether the human need to ritualize endings, the countdowns, the farewells, the poetic press releases, is scientific or spiritual. Probably both. Every departure teaches scale. How small we are, how far curiosity reaches anyway. The comet's path now crosses the threshold where the sun is no longer a sovereign star but just another bright point behind it. The dust tail, invisible to ordinary optics, remains visible in radar scatter as a faint ribbon of charged particles aligning with galactic magnetic fields. Instead of pointing away from the sun, the tail now bends toward the galaxy's center, as if paying respect to a new gravity. For the first time, ATLAS belongs to no system at all. You imagine riding alongside it, the solar system shrinking behind like a string of fairy lights, the stars ahead sharp and merciless. There's no sound here, only the vibration of motion, the endless hiss of distance. You'd see the constellations slowly distort, the familiar outlines stretching as parallax reveals their true separation. A year from now, Earth will have moved on in its orbit, and ATLAS will already be another ghostly entry in catalogues, magnitude unknown, fading rapidly. Yet even as it disappears, its influence lingers. Models built to explain its weird tail now reshape plasma theory. Its chemical fingerprints rewrite the textbooks on interstellar ice, and the questions it raised about direction, acceleration, maybe even intention, become the seeds for a dozen doctoral theses. Every time knowledge advances, it leaves behind myth compost. Atlas will be fertile ground for both. You think of earlier visitors, 1I/Oumuamua, 2I/Borisov. Each carried a chapter of interstellar autobiography. Atlas feels like the trilogy's finale. Not closure exactly, but maturity. By the next one, humanity might have better telescopes, faster probes, maybe a plan to intercept. The comet that taught us confusion might be the reason we finally learn to greet the next stranger in person. The outbound telemetry shows one last curious kink, a microscopic lateral wobble, perhaps a final vent of gas, or the two fragments finally drifting apart for good. It's small, a few centimeters per second of divergence, yet in a million years they'll be light years apart. Separation and freedom are measured the same way in space, distance increasing forever. You lean back and let the quiet take over. The fan hum you once imagined as cosmic static now feels like translation, the background noise of things leaving. Somewhere far beyond Neptune, a teal shimmer fades into invisibility, dragging our collective wonder behind it like a wake. Gravity lets go, and so must you. Time passes, months, maybe years, and the world's telescopes turn their gaze elsewhere. The sky never stays short of mysteries, and 3I/ATLAS has become another archived dataset, a bookmark in humanity's slow crawl toward comprehension. Yet its influence lingers like cosmic perfume. The questions it raised about how we watch, how we interpret, how we dream, have already reshaped the instruments being built for the next visitor. You picture the scene at the Jet Propulsion Laboratory. Engineers leaning over blueprints for a new kind of eye. A wide-field space telescope designed not just to track asteroids, but to catch anything crossing the solar system, no matter how brief its hello. The mission planners toss around names. Someone jokingly suggests ATLAS2, then half-seriously scribbles it on a whiteboard. The Comet's ghost hovers over every new design decision. Faster data pipelines, smarter detection algorithms, a readiness to notice the unexpected. A mainstream historical fact, the Vera C. Rubin Observatory, under construction in Chile since the 2010s, was built for exactly that, to image the entire southern sky every few nights, turning the heavens into a movie. Historians still argue whether it marks the end of astronomy as solitary romance and the start of astronomy as big data. Atlas's performance strengthened that trend. It proved that even the faintest anomaly can rewrite whole disciplines if you watch closely enough. You can almost hear the future forming. Telescopes orbiting the sun at opposing angles, relay satellites passing terabytes between continents, machine learning systems scanning for patterns our eyes can't see. They'll find the next interstellar wanderer sooner, maybe even early enough to send a probe. Already, the European Space Agency's Comet interceptor mission, scheduled to wait in orbit for just such an opportunity, has upgraded its contingency plans because of Atlas. The engineers call it the Atlas Protocol. Never assume behaviour will be normal. At night, in classrooms and online lectures, professors use ATLAS as a case study in humility. The slide decks always start with its teal tail bending toward the sun, then zoom out to the orbital kink that broke our equations. Students whisper to one another, half in awe, half in glee, because it's proof that the universe still surprises even the adults. The comet has become a myth of modern science, a reminder that certainty ages faster than curiosity. A quirky tidbit surfaces. After Borisov's visit in 2019, a startup tried to trademark the phrase interstellar delivery service for hypothetical comet mining missions. The idea sank quickly. After Atlas, the name reappears, this time proposed by artists planning a message in a comet project. Tiny encoded sculptures to be launched toward the next inbound object. They want to answer whatever Atlas was saying. You can't decide if it's absurd or perfect, so you settle on both. Meanwhile, astronomers refine their predictive models. Statistically, a new interstellar object should cross our skies every few years. Some will be dull, some dramatic. One might carry organic compounds, another magnetic anomalies. Each will force us to relearn the same lesson, that the galaxy is not empty, just patient. Historians still argue whether this flood of visitors means our solar system sits in a busy stellar neighbourhood or whether we've simply grown clever enough to notice the traffic. Either way, the night has gotten crowded in the best way. You imagine standing in the near future beside one of those telescopes, perhaps the giant ELT in Chile, its mirrors larger than apartment buildings. You're older, but the excitement feels the same. Someone announces a new detection. Faint, fast, hyperbolic. The room goes still, that perfect breath before wonder. The young technicians start running orbital solutions, cross-checking catalogues, déjà vu flickering in every keystroke. We might have another interstellar, one whispers, trying and failing to sound calm. For a moment you think of Atlas out there, light years ahead now, perhaps drifting past another star's Oort cloud, unseen, its fragments long separated. Maybe it's melting under alien sunlight. Maybe it's colliding with another wanderer. Maybe it's simply gliding through the void unchanged. The physics doesn't matter so much anymore. It's the continuity that stirs you. One comet teaches us. Another arrives to test what we've learned. The universe is a syllabus written in dust and gravity. You smile, recalling a professor's favourite line. Every observation is a rehearsal for the next surprise. Atlas made that sentence gospel. Its tail might be gone, but its afterimage glows in every funding proposal, every lab argument, every stargazer's imagination. It turned data into anticipation. Outside, clouds slide across your window, faintly lit by city glow. Somewhere beyond that glow, the next traveller is already inbound, invisible but inevitable. The new telescopes will spot it, algorithms will analyse it, scientists will argue over it, and you'll still be here, waiting, just like always, ready to let another impossible speck rearrange your understanding of everything. It's strange how easily you start thinking of it as ours. A comet born around another sun, a wanderer we borrowed for a heartbeat, and yet when people talk about 3I/ATLAS now, they always say we lost it, as if it belonged to us all along. Ownership by observation, you suppose? We study something long enough, and it becomes family. You picture the post-mission panels at conferences, sleep-deprived scientists sitting under fluorescent lights, their slides full of colour-coded graphs. Every talk begins with the same image, the comet's teal halo, and ends with the same confession. We still don't know. The honesty feels refreshing. Science, at its core, is institutionalized bewilderment. A mainstream historical fact. When Galileo's contemporaries mocked him for suggesting Jupiter had moons, he offered to show them through his telescope. Many refused to look. Historians still argue whether that refusal was fear of being wrong or fear of changing their world. Watching the reactions to ATLAS, you see the same nervous laughter, the same quiet awe. Curiosity is courage dressed as confusion. Beyond the equations, something softer has happened. The comet became a mirror for our own reflexes. The early panic, the myths, the debates, they all revealed a species desperate to make sense of strangeness. Even our skepticism was emotional. "Why does it matter so much?" one interviewer asks a leading researcher. She smiles. "Because mystery reminds us we're alive." You think about that while scrolling through art projects inspired by ATLAS. Watercolour nebulae shaped like tails. A sculpture in Tokyo that uses liquid nitrogen mist to mimic its breath. A lullaby composed entirely from the sonified data of its light curve. In classrooms, children write stories imagining the comet as a traveller collecting memories from planets. A teacher posts a photo of one essay that begins, "Dear Earth, I saw your ocean sparkle and I hope you're okay." You feel a lump in your throat. Historians still argue whether awe has any practical value. Economists can't quantify wonder, yet funding for astronomy spikes each time a comet like ATLAS visits. Turns out meaning is a renewable resource. People crave it more than certainty. Even skeptics admit the comet shifted something subtle in how we think about belonging. Before ATLAS, interstellar space felt theoretical, numbers on chalkboards. Now it feels close. We've touched something that touched another sun. The galaxy stopped being a backdrop and started being a neighbourhood. A quirky tidbit. Anthropologists studying online discourse around Atlas discovered that comments mentioning hope outnumbered those mentioning fear by a margin of 3-1. That's rare for anything labelled mysterious celestial object. Usually the ratio flips. Maybe, they suggest, humanity's default mood is quietly improving. Meanwhile, in dark domes and quiet labs, researchers keep combing through the leftover data. They find no hidden message, no deliberate pattern, just complexity masquerading as intent. Yet every new paper ends with a sentence like, "Further study recommended." Translation: we're not ready to let go. You lean back, eyes half closed, thinking of the chain of watchers that led here. The Babylonian priest marking clay tablets, Tycho charting the 1577 comet from a cold Danish island, Carolyn Herschel sketching with a candle guttering beside her notebook, the engineers who built Atlas's namesake telescopes, the students now coding machine learning sky surveys at 3 a.m. A single thread runs through them all, people refusing to look away. Outside your window, a thin crescent moon hangs like punctuation at the end of a very long sentence. Somewhere beyond it, ATLAS is already part of another sky, invisible but still radiating the faint signature of its strange chemistry. A million years from now, some other civilization might detect that trace and argue over its behaviour the way we do now. They'll invent their own theories, their own myths, maybe even name it after themselves. You find the thought comforting. Knowledge is a relay race, not a possession. Historians of the future will probably laugh at our primitive debates, quantum ice, alien probes, plasma mirrors, but they'll recognise the emotion beneath them, that hunger to connect dots across light years. The comet was a question written in ice, and we answered with art, argument, and affection. That's a good conversation by any cosmic standard. You exhale slowly, letting the hum of your room fill the silence. The story feels almost finished, though you know space doesn't do endings. Out there, Atlas drifts on, indifferent to every headline, carrying with it our collective reflection. A record of what happens when a small, curious species sees something impossible and chooses wonder over fear. You imagine it one last time, the teal shimmer barely visible against the infinite dark, the twin fragments long separated but still tracing parallel paths through the galaxy's faint electric haze. 3I/ATLAS has become what all wanderers eventually become, rumour wrapped in physics. And yet you can't quite stop watching the place where it used to be, as though absence itself now emits a kind of light. Astronomers finally sign off their reports, object lost to follow-up, apparent magnitude below detection threshold. The phrase sounds clinical but reads like grief. Observatories turn their domes toward other coordinates, other curiosities. The sky doesn't pause, it never has. But in every data set, in every calibration file, there's a faint echo of teal, the residual curve of a mystery that refused to fit. A mainstream historical fact. When Halley's Comet faded after its 1910 pass, people wrote letters to newspapers describing phantom tails lingering in the night sky for weeks after. Optical illusion, yes, but historians still argue whether that shared vision marked humanity's first collective acknowledgement of nostalgia for something cosmic. A century later, we're doing it again, only now through data instead of dreams. In the months following Atlas's departure, journals overflow with analyses, dynamics of a hyperbolic binary, spectroscopy of interstellar ice anomalies, potential non-gravitational mechanisms and fragmentation events. Each paper ends with the same polite uncertainty, open questions disguised as conclusions. The more we learn, the less solid the comet feels, as if knowledge itself is melting it into mist. A quirky tidbit: a graduate student in Prague, inspired by the comet's rhythm, converts its brightness fluctuations into musical notes. The result is haunting, slow, minor, drifting between order and chaos. She uploads it at 2 a.m. with the caption, "A lullaby for something that never belonged to us." Within a week, it's being used in meditation apps worldwide. You grin at the thought, an interstellar object turned into a human sleep aid. That's cosmic recycling at its finest. Back on Earth, a few dreamers keep searching. Amateur astronomers track possible return trajectories centuries into the future, knowing hyperbolic orbits don't come back. Still, they plot the numbers just in case, drawing elegant spirals on screens comforted by the motion itself. Historians still argue whether astronomy began as science or therapy. Watching them work, you'd vote therapy. The legacy thickens quietly. Theories sharpen, instruments improve, and the next interstellar arrival, whenever it comes, will find us more prepared. But something subtler has shifted too. The public no longer treats alien as an answer, but as a question. Atlas taught that you can wonder responsibly, that awe doesn't require surrendering reason. That might be its greatest discovery of all. You sit back and feel the weight of it, 20,000 words of whispering through dust and data, following a speck of ice across the void. The room hums with that low fan rhythm you've turned into cosmic metaphor. Outside, city lights flicker like small, stubborn stars. For a moment, the whole planet feels like one observatory, 7 billion quiet listeners waiting for the next impossible thing to happen. Historians of the future will file Atlas among the transitional stories, the ones that bridge superstition and science, anxiety and awe. It will live in textbooks and bedtime stories alike, a parable about humility hidden in astrophysics. Look up, notice, don't assume. That's the moral, if the universe ever writes morals. You close your eyes and picture it far beyond the heliopause now, sunlight only a memory, tumbling slowly through a thin sea of galactic dust. Its surface is inert, maybe cracked, maybe glistening. No tail, no warmth, only momentum, the purest kind of motion, unbothered by destination. It's easy to imagine the fragments glowing faintly as they spin, each rotation a silent reminder of all the questions they left behind. Maybe someday, millions of years from now, it will drift close to another star. Someone else, alien, human, or something we can't name, will notice a faint teal smear on their sensors, and ask the same questions we did. And so the conversation will continue, stitched across epochs by curiosity itself. You inhale, exhale, let the hum of your fan become the sound of solar wind. The story settles, the comet fades, but the act of looking, that stays. That's the inheritance Atlas leaves behind, an invitation not to stop. So you don't. And now, as the data screens dim and the hum of distant machines gives way to the quieter hum of your own breathing, let the story drift outward. The comet is gone, but its trail hangs in imagination like phosphorescence after a wave. Every mystery leaves a glow for those willing to sit still long enough to see it fade. You let the language slow, syllables stretching like light years. The edges of thought soften. You picture Atlas somewhere far beyond the reach of numbers, no longer fragmenting or spinning, just gliding through a velvet ocean of cold and calm. No gravity tugs, no observer's measure. It moves because motion is what time becomes when everything else sleeps. The fan's steady breath turns into cosmic wind. Your heartbeat syncs with the distant rhythm you once called a signal. It's not a message, it's continuity. The same hush that fills observatories at dawn now fills your room. The same curiosity that launched telescopes now keeps your eyelids heavy. Wonder, it seems, is just a quieter form of rest. So you exhale, letting the last bits of static dissolve. The comet keeps going, and so do you, though in smaller orbits. Coffee cups, alarm clocks, the turning of a world that's still spinning beneath infinite stars. Somewhere above, photons from 3I/ATLAS are still travelling, a soft teal whisper stitched through the dark. They'll take centuries to fade, but by the time they do, you'll already be dreaming. Good night, traveller. Sleep easy under your own small sky. The universe is still out there, steady and strange, watching back with gentle indifference.